Hello everyone and welcome to this last video of IT network addressing. My name is Gaspar Mbole, your IT network engineer with Smart Technology Consulting. So this last video is concluding what we've been talking concerning the addressing, and if you did not watch the previous videos, I will invite you to go and read them and watch them, because we explained what addressing is all about and where we use it, as well as the little math that go in the binary and decimal stuff. Very interesting. You may want to go and read. On this particular video, we're going to talk about the network mask on IPv4, the address classes and address types. We're going to talk about the subnetting, the fixed length subnetting mask and the variable length subnet mask. And we'll conclude with the IPv6. The good thing is, when we're talking about network mask, it applies to IPv6 the same way it applies to IPv4. So, what is important here to notice is that the network mask, right, they have the same format as the IPv4, that is 4 octets. And the reason is because we're going to use that format to identify in the IP address which bits are representing the network ID and which one represent the device ID. That's why we're going to use what we call the masking bits, right? So we are going to mask the bits that represent the network by giving them a value of 1 on the equivalent position of the network mask, and the one that represent the device are going to receive a 0 value in the network mask. And we have to know that these bits have to be continuous. If you take the example of the masks there, the first one is a valid one because we have a set of 1, then a set of 0. We cannot have a 0 in between ones. That's not going to work. That's an invalid format. Now let us take this IP address, that is 10.20.30.59. If we give it the mask of 255.255.255.0, we have a separation of 2 identification. The block in red represent the network, and the block in blue represent the host. As you can see in the network mask, the 3 first octets are all in one, so they are masking the first 3 octets of an IP address. The consequence is that all the devices in that network will have the 3 first octets identical. And what is going to vary from one device to the other is the last octet. Based on that, the network ID or the network identification is going to be 10.20.30.0. And the CIDR notation, CIDR stands for classless interdomain routing, is going to be 10.20.30.0/24. Why /24? Because we're masking the first 24 bits. That's what the network mask is doing. And if we want to know how many IP addresses, valid IP addresses we can use in this space, because we're going to change value on the blue octet, what are we going to use as a formula? It's going to be 2 at the power of 32. 32 is the size of the entire octet, minus small n, that is minus the number of bits that we are masking that are not going to change. And then we remove 2. Of course, we're removing 2 because the first IP address is the network identifier, and the last IP address is the broadcast. That is when we want to talk to everybody. We'll have a video to explain the concept of broadcast and others as we move on. Based on this formula, we can see that the number of IP addresses that we can use here is 256, but the number of valid IPs is 256 minus 2. That makes 254 IP addresses that we can give to devices. Now we have, in this addressing stuff, IP addresses, we have different classes of addresses, right? And we're going to differentiate these based on the first octet. The first octet. So we have class A, and the first octet is going to be from 0 to 127. That's how we're going to recognize an IP address as being of class A. Class B will have the first octet from 128 to 191. Class C is going to be an address that has the first octet from 191 to 223, right? And class D, that is used for multicast, we'll talk about multicast in future videos, will have the first octet from 224 to 239. The remaining addresses from 240 to 255 are special addresses that are for class E. So that's how we differentiate the classes of addresses. You have to note that it is not based on the subnet mask, but on the first octet. And then we have two types of addresses. We have the private addresses, those that can be used in our private infrastructures, right? And we have the RFC 1918 that identifies these spatial ranges that can be used in our company, in our homes, right, safely. All the other ones are going to be routable on internet. So we have to make the distinction here. The private IP addresses are used within our infrastructure, and they're private, they're not routable on internet. The other ones are routable on internet. Then we have what we call the APIPA, the automatic private IP addressing. These are the self-assigned IP addresses for a device that was set on DHCP and could not find a DHCP server to request an IP address. So it's going to assign itself an IP that is just not routable. AWS is making some use of it, but in general, they are just not usable. Then we have a good concept here that we want to discover, the subnetting. That is, we can take a network and divide it into chunks. We do this by borrowing some bits in the network. So as you can see here in the example we have, the IP address is going to be network.network.network.host, right? So we've taken a /24, that is, we're masking 24 bits. And then we have 8 bits that are reserved to identify host. But we may want to group this host within the network. That way we can borrow, let's say we're borrowing 2 bits. What is going to happen here is that by borrowing these 2 bits, we can form 4 groups. The first group with the bits value 00, the second group with the bit value 01, the third one will have the bit value 10, and the last one will have the bit values 11, right? And if we want to know how many groups we can have, just do 2 at the power of the number of bits that we borrowed. Here we borrowed 2, 2 at the power of 2 is 4, very easy. And then we're going to have subnet 1, subnet 2, subnet 3, and subnet 4 to represent the 4 groups that we can have by borrowing 2 bits. You can extend the example by borrowing 3 bits, and then you will understand better. We can do this, by using, let us take an example so that we make it easy. 192.168.57.0. As you can see, we have 24 bits masking the network. If we borrow 2 bits, we're going to have this result. The last octet, where we're borrowing the bits, can have these 4 values to represent our groups, right? You can determine the decimal value of these octets. You can refer to the previous video to make it easier to understand. That way, we're going to have these 4 subnets. That is, subnet 1, subnet 2, subnet 3, subnet 4. And the IP addresses we have here are subnet identifier. You can determine how many valid IP addresses we have in each of these subnet by doing 2 at the power of 32 minus 26, and then you remove 2. That will give you 62 IP addresses that we can use, right? Very easy. If we split a network, equally, we're going to use what we call the fixed length subnet mask. That's the example we had before. That is, we're just borrowing, 2 bits, and it becomes consistent for all the groups that we create within that network. But it doesn't mean we can only do that. We can tweak a little bit, borrowing 1 bit here, 2 bit there, 3 bits there. But it has to be done very accurately. That's what we're going to call the variable length subnet mask. We have to borrow these bits and avoid overlapping. Let us take an example here. Same network, but for the first group, we can borrow 1 bit. If we borrow 1 bit, it means that we have divided our network into 2 groups. So one group is going to be used for subnet 1. The other one is going to be available to be divided again. And we can borrow now 2 bits to divide that into 2. That will make like a quarter. And then a quarter will remain, where we can borrow 3 bits to divide it into 2. We get 1/8. And we're borrowing from the initial network, of course. That's what we get, this result we have here. The subnet 1, that is 192.168.57.0 with /25, because we borrowed 1 bit. The remaining space is going to start at 128, where we can also divide into 2. That's going to take from 128 to 191, and the remaining space is going to start at 192, that we can also divide into 2, right? That becomes variable. That's what we call it, variable length subnet mask. Now let us just have a little word about IPv6. I think we spoke about everything we want to know concerning IP addresses. The same philosophy we have concerning the network masking on IPv4 goes to IPv6. But here I just want to emphasize on the fact that we have 3 types of IP version 6 that are global unicast addresses, can be used on internet. We have the unique local that can be used, in a private environment, like the RFC and 1918. And they have the link local addresses that are like the APIPA addresses. So that's what we can say concerning this video, this addresses usage and the network mask. So we want to thank you for watching this video. And if you have a question, please send it in a comment. And if you want to share a thought, please do the same. And if you have not yet subscribed in our channel, we encourage you to do so that we can all be smart in IT networking. See you in the next video. Thank you.